Hello everyone, this is Mrs. G. I'm going to give you a quick little video of what I would be telling you if I was there in person. So, first of all, what you see here is the outline for our brand new unit. This is our final unit of the school year of grade 8, and it is called Simultaneous Equations. So now we're looking at a group of two algebraic equations, and we're trying to find the solution. Our lesson for today here is lesson 1. We are going to just review something that we've done already. So hopefully there should be some, I don't know, digging back into the cobwebs and recesses of our brain. This should at least feel familiar. Graphing straight lines is where we're going to start with. Okay, so if you haven't glued this in your notebook, please do that now. But let me give you a little intro of where we're going. Okay, so this is unit 7, and we are going to go into two linear equations. Okay, so and looking for the solution of two linear equations. All right, so what's a linear equation? Let's just do a quick little review. A linear equation or a linear function, if you remember back from unit 2, is one equation that has two variables. So commonly we use x and y. You'll find out in a second. So here's a real simple one, x plus y equals 10. There's lots of little pairs of numbers that would satisfy this linear equation. You could say maybe the most obvious one you might see is 5, 5. But also there's, 1 and 9 and 2 and 8. And yes, 8 and 2 is a different solution. One is x equals 2 and y equals 8. The other one is x equals 8 and y equals 2. I couldn't remember which one I said. Sorry. So there's many different things that satisfy, that make this equation true, that would kind of work inside of that equation if you were to plug them in. Also, don't forget we do exist in a world of negative numbers. We do exist in a world of, fractions. And so there's actually an infinite number of solutions. It's not that every single thing is a solution, but there's an infinite number. So now we start asking ourselves, how do we understand, how do we make a picture, how do we diagram the solution when there's an infinite number of them? And the quickest answer is to say, well, we can graph these. So we have x and we have y. If we were to turn our solutions into coordinates, if this is where x is 10 and this is where y is 10, we got 5, we got 5. You could start making points where each one of these dots would exist here on the coordinate plane. So 5, 5 is here, 8, 2 is around here, and we'd have 10 and 0 and 0 and 10. So mine are not in the best of positions. Why is that not working? But in theory, if you connect these, you'll get a straight line. You'll have to trust me. You'll get a straight line, yeah? So the blue line is really kind of a graphical picture of the solutions. Any single dot you could choose, making any point that I wanted to on that line. Those are all solutions to this equation here. Okay? Now, maybe, just maybe, we can think about this equation in a slightly different form. Okay, instead of writing x plus y equals 10, we could solve for y, meaning get the y variable alone. Y equals minus x plus 10. This helps us because you can see some more connections. You can see kind of how this connects a little bit better to your graph. All right, if you remember, back in Unit 2, we talked about things like gradient when we started talking about straight lines or slope, and that's the steepness of the line. And we also talked about kind of x and y intercepts. Okay, so something I want to review today heavily is this kind of form of a line. We call this slope intercept form, or you could call it a formula, I guess, as well. And what happens here is the main idea is that the y value is alone. Okay, so y is all by itself. Y equals is how these things start. And the number that comes in front of your x, okay, well, what comes in front of x here? If you don't see a coefficient, you always want to slide in a 1, because 1 times x is x. And so the coefficient in this situation is -1. Okay, maybe you might see how our line, our blue line up here, has a negative slope. It's going down. Okay, you'd be kind of walking down the mountain, right? And the slope of that line is -1. Well, if I had better graph paper, you could see that. And we're going to do a Desmos today where you'll be able to see this a lot better. You can count down 1 and over 1. You can count down 1 and over 1 for every single one of these points here. Down 1, over 1, that's the slope of this line. Okay, also called gradient. Either one is perfectly fine, obviously. Okay, so that is a negatively sloped line. It's going down. We can see that. If you were to kind of look at your coordinates here, you might kind of see how this one, where's an example? I don't know if I have a good one. If you were going from 5 here to 4, you'd go down 1 to get to 4 as you go. That's not a great way to look at. Disregard what I just said. Okay, the slope of that line is -1. And the 10 here is another key piece. The constant that comes at the end, the +10, the -7, the +4, whatever happens to be there, that's going to be called your y-intercept. That's a single point. And what it is where your line hits the y-axis. Please tell me a little this is sounding familiar, hopefully. Okay, so that's your y-intercept. So the first thing we want to do for today's lesson is just kind of go back to this really key idea of linear functions, and that being slope-intercept form. And I have it here in a pretty little orange box. Okay, so grab your notebooks. Let's write this down. Y equals mx plus c is one of these things that the sooner we commit to memory and we just kind of make sense of it, the better math class gets in a lot of ways, because this is going to come up next year. It's going to come up a lot anytime we're talking about linear functions, things that have constant change. Remember, this is not an exponential function, which we just did. Things that have kind of multiplications as we get bigger. This has constant change. Okay, so grab your notebooks, write this down for me, please. Y equals mx plus c. Make it nice and big, make it nice and bold. The coefficient that comes in front of x is going to be the slope or gradient. The constant that's going to be at the end, that's your y-intercept. At this point, a lot of students will ask me, Ms. G, but what are x and y? And I'll say that's a great question. The x and the y, those are variables that will always exist in any linear function. And the x and the y really stand for any possible combination that could work. So going back to my very simple example, if you'll stick with me up here, in this equation here of x plus y equals 10, okay, what are x and y? Well, they're 5 and 5, for example. They're 1 and 9, for example. Okay, there's lots of different things that x could be and y can be, as long as they fit, as long as they make this statement true, as long as they fit the equation like they're supposed to. Okay, so x and y will always be there, and x and y are simply the different combinations, the different solutions that would make that equation true. Okay, so write that down. Pause me. And when you're done, let's do a quick analysis here. Real quick, some equations here. Y equals 2x minus 3. All right, all we want to do is say, okay, what is m and what is c? I'm going to pause for a 2-second break, and feel free to say this out loud. I swear no one will laugh. No one will hear you. They're all tuned in. So m equals, in this first example, m equals 2. C equals minus 3. Okay, so we're pulling these out of the equations themselves. The next one, m equals, that's a tricky one, 1. Okay, again, sneak in a little coefficient of 1. And c equals 5. The next one, m equals minus 3. C equals 2. The next one, m equals 2. C equals, another tricky one. What could I put here that would not change the value of that equation at all? If I start with 2, real simple. If I have 2 pencils in my hand, I want to add something and still have 2 pencils in my hand when I'm done. You're going to add 0, right? So C is 0. This equation here would go through the origin. It would go through that intersection point right in the center of where x and y collide. All right, the next one, I move things around slightly. M equals -2. Okay, we're still looking at the coefficient on x, even if they kind of switch places slightly. And C, the constant term is 5. And then the last one, real sneaky. M equals, the C is easier because there's still a constant here. C equals 3 and M equals 0. This, ladies and gents, is a horizontal line where y equals 3. So if that's your x-axis and your y-axis. Anyways, okay, so pulling out x and c, m and c from some slope-intercept form. And now we're going to practice our graphing. One thing I forgot to mention, maybe you want to go back up to here, slope or gradient. Key idea, we want to write down rise over run. Okay, if you're finding the steepness of a line, you're simply going to count the boxes in between two different points on your line. Counting the rise first, putting it as the numerator, the up or down, and the run horizontally. Okay, so that brings up one other key idea I want to remind you so you don't get confused later when I'm not there. All of these m values are actually easier, maybe the one time in your life, they're easier when they're fractions because then you have a rise and a run. So how the heck am I going to count out a slope of 2? Okay, for example, we might do a few of these real quick. This first one, y equals 2x minus 3. All right, real rough little coordinate plane here. Your starting idea of when you want to graph these is actually starting with your y-intercept. So the first point is going to exist at minus 3. Okay, so go down on your y-axis. The y-axis is the vertical one. This is the x. Go down to minus 3. And then from that red dot that I just made, count 2 over, that's tricky. Okay, if I want a slope of 2, I think 2 over 1. Okay, 2 whole pizzas can also be written down as 2 over 1 whole pizzas. So from the red dot I just made, count up 2 over 1. And that is your next point. Okay, you could keep going if you wanted to. Up 2 over 1. All of these dots should make a nice straight line when you connect them. Okay, so hopefully this is coming back slightly. Rise over run. Okay, maybe we'll do one more quick one, just so you know what to do in a moment when you start your activity. Let's do the second one. I'm going back to this one here. So y equals 1x plus 5. How am I going to graph that? All right, hopefully you're saying to yourself, start with 5, Miss G. I heard you. I heard you through the internet. All right, so start with 5. 1, 2, 3, 4, 5. Okay, so we count up 5 on our y-axis, and now my slope is 1. M equals 1. Again, if it's a whole number, if you happen to see a whole number, put it over 1 and count up 1 over 1. Ooh, could you go down 1 and back 1? Sure, but now I'm getting fancy. You don't have to get fancy. All right, so that is the linear function there of y equals 1x plus 5. Okay, so just a quick little review on graphing. I'm hoping that you're all set to start a Desmos activity. Okay, so now you're going to head to student.desmos.com and you're going to do an activity called Match My Line. Okay, I have a moment here. You can come back to me if you're confused on challenge number 2. So pause in this moment, get started, get going. If you get to challenge number 2 and you get stuck, come back to me. All right, here I am. If you happen to be stuck on this one, Miss G, what's going on here? All right, so basically, what it says is plot 6 lines. Each line should pass through the origin. Okay, so remember the origin is here, and one of them is done for you. Okay, so they've clearly done this red one here. That is y equals x. Y equals x, remember, if you want to think about what is actually happening, y equals 1x plus 0. So this goes through the origin and has a slope of 1. The slope of 1 is simply up 1 over 1. Up 1 over 1. Hits all the kind of corners. Y equals x, I always think about kind of as that one that's the 45-degree angle, right? All right, so how am I going to make this line here? How am I going to make that line there? How am I going to make that line there? That's what you guys have to do. You have to find all those other 5 points. Okay, don't just guess and check until you happen to get it right. All right, all of these are going to have a y-intercept of 0. So you're not going to really have any coefficient, or any constant term to add there at the end. But what you do want to do is count the slope that you need. All right, they're all going to go through here. And if you want to start here, which makes a lot of sense, start counting boxes. 1, 2, 3, 4, 5. 1, 2, 3. All right, so your slope here is 5 over 3. All right, y equals 5 over 3, right? Oh my gosh, I put it in. Y equals, that doesn't seem to work. All right, you forgot the x, people. Okay, don't forget, x and y have to exist in your equation. And how do you signal, okay, this thing is the slope? Well, it's the number that you put directly in front of x. Okay, so if your slope is 5 over 3, you need a multiplier of x to come right after it. Okay, so hopefully that's the first one, and you guys can go from there. All right, be aware, obviously these down here are going to need negative slopes. So down. Okay, counting slope that goes down needs a negative. Okay, if I go down here, minus 2 over 3. Okay, so see if you can finish that activity. I think you can. Feel free to work together if you get absolutely stuck. Stop at slide 10. Oopsie, I don't know why I wrote 100. Stop at slide 10. And if you're really, really, really stuck on slide 9, you can stop there as well. Okay, when you're done, you're going to do like a little worksheet that is about who do you see at the bank if you need a loan. Okay, so simple stuff, hopefully. Y equals mx plus c with a little fun with some Desmos. Okay, if you guys have questions, I'll be back on Thursday. Right? Thursday. All right.